Hello, everyone. Welcome to the second part of the Scientific Reasoning Module 2. This module will focus on food fraud, honey investigation. My name is Huihui Wang. I am Associate Professor at Department of Agricultural Science, Education and Communications, Purdue University. This professional development is part of an industry-driven, integrated STEM and system approach to innovate incubation project. The project is funded by USD and NIFA, and there are 5 modules in this series. The modules will use the roadmap to guide your learning experience. The second module focuses on the type of scientific investigation, which is an important component of the scientific reasoning. Scientific investigation involves process of inquiry, experimentation, evidence evaluation, inference, and interpreting results that support or refute the hypothesis. Module 2 is dividing into 2 parts. This is the second part of the Module 2. In this module, we will focus on conducting experimentation as a scientific investigation. Let's review the type of scientific investigation. Observations and experimentations are the 2 words that you often use a lot in your teaching. Both observations and experimentations are considered as a way to conduct scientific investigations. In the first part of the module, we focus on making an observation. And for this module, we focus on the scale of conducting scientific investigations for the experimentation. As a PK-12 educator, you must know the importance of teaching your students to conduct scientific investigations. Besides observation and experimentation, there are other components that relate to scientific investigation. You probably already know that first, a textbook question is the first step of forming a hypothesis. A textbook question is based on evidence and can be measured and observed through scientific investigation. Yes or no questions are not textbook questions. Why questions might not be textbook questions? Because they might not be answered by direct observations or by evidence that could be gathered from the experimentations. Please note that inquiry motivates students to generate textbook questions. In addition to that, inquiry also is an important skill that students need to ask good textbook questions. After a student has a textbook question, the next step is to form a hypothesis. A hypothesis is an assumption about a possible answers or solutions based on limited evidence as a starting point. For field investigations, some teachers also refer to hypothesis as an educational guess. After students has a good hypothesis, the next step is to design an experiment. This process involves develop appropriate experimental procedures that might have dependent, independence, and control variables, and also needed to have appropriate data collection plans. Please review what are the dependent variables, independent variables, and control variables. When you teach how to conduct scientific experiment, have you discussed with what is credible scientific evidence with your students? Although evidence that are gathered from scientific investigations are called scientific evidence, but a researcher's experimentation skills, such as how he or she collect data, analyze, and interpret data, will have an impact on the results of a scientific investigation. So there is no perfect experimental design. Flaws always exist in the experiment design. Let's continue to use adulterate honeys as a context to further discuss the scientific experimentation. Honey is a complex mix of sugars which varies according to the regions it comes from, the flower sources, and the time of harvesting. Designing a test that can work across a regions of honey products and pick up the adulterate one is a serious scientific challenge. To measure the quality of honey, USDA set up a guideline to measure certain components of honey, such as moist, contents, colors, clarity. However, does the US grade A means the highest quality of honey? If you go to supermarket and you buy the USA grade A honey, does that mean that you buy the pure honey? In fact, some honey might be import from other countries, such as Mexico or India, could also be labeled as US grade A honey, even they are not made in USA. As we have discussed in the previous model, honey can be changed in many ways. It can be diluted with the different kinds of sugar or syrup. Some new technology can also change the substance in the honey. Take India gum honey as example. It tastes and smells like old jean sock. You can't sell it because nobody wants it. It smells bad. However, if you dissolve it in the water and do some rinse and treatments, it will get rid of the malodors, and you now can sell the honey. Honey also can be ultrafiltered. For example, if you have honey coming from China, and then you dust it with Argentina pollens, voila, after mix it up, it becomes Argentina honey. Also, beekeepers can also overfeed bees with the sugar to yield more honeys from hive, which those are honey not from nature environment. Now you see, there are so many different ways to make adulterate honey. To detect adulterate honey, scientists are continually exploring rapid, sensitive, and efficient recognition systems through innovative technologies. We have shown these figures in the previous model. Now this might make much better sense to you now when you think about adulterate honey. In this part of module, we will focus on the sugars and the sugar syrups at adulterate honey. Now, you will use the worksheets in the Google Classroom to complete this activity. You are a food chemist who work at Sweetwater Science Labs, which is an independent test lab in Missouri. You receive a test request to determine the biochemical property of honey samples to distinguish between the adulterate, which is sugar and or syrup add, and pure blossom honey. You got some help from Mr. Hyatt. who is the vice president of the American Honey Producers Association. He will give you access to National Directory of Beekeeper. You will set up an experiment to test the differences between the pure blossom honey and adulterated honey that produced after bees are overfeeding with sugars. As a food chemist, you know the quality and the biochemical property of honey are related to honey maturity, production methods, climate conditions, processing, and storage conditions, as well as the nectar source of the honey. You decide to test the following 6 biochemical properties of the honey sample to distinguish between the adulterated and pure blossom honey. Please use the worksheet. Tell us, what is your inquiry? What is your hypothesis? How will you set up your experiment? For example, what type of honey samples do you need? How will you design your experiments in terms of collecting honey sample? Please pause this video for 10 to 15 minutes to complete the worksheet. At this point, you do not need to fill the answers of the question number 4 and number 5. Welcome back. Do you think you have a good experimental design? Here are 2 examples of experimental designs and the results that are from real scientists. In the experimental one, the scientists work with the local beekeepers. The scientists set up control and experimental group. In the control group, bees only collect food from natural environment. In the experimental group, bees are feeding sugar water with a ratio of 1 to 1.5. In the experimental 2, examples are from 6 colonies. The scientists feed colonies with different levels of various industrial sugar syrup. Syrup was given to the experimental colonies at the different intervals, twice for the 5 liters colony, 8 times for the 20 liters per colony, and 40 times for 100 liters per colony. The scientists also collect honey from bees are feeding in a nature environment as a control group. We present part of the results from these 2 studies, as you can see in those 2 tables. Please know that those 2 experiments collect honey from different regions, even though they were the same authors, first authors. In addition to that, the scientists given different amounts of mixed sugar water and the type of sugar that set up experimental group in those 2 experiments. As you can see, the result shows the differences between the 2 experiments. The nature groups actually has a higher moist in experimental 1 and fruit acidity than adulterate groups in the experimental 1, but it reversed the results in the experiment 2. The rest composition are pretty similar between natural groups and adulterate groups for the experiment 1 and experiment 2. Now, how would you interpret the data that we provide? Based on the results from the previous slides, experimental 1 and experimental 2, what is your conclusion? What evidence supports your conclusion? What evidence does not support your conclusion? What further study inquiry would you like to do? What other information would you like to know? For example, general or technical or scientific. Now, please pause this video again and spend few minutes to complete the worksheet, question 4 and question 5. If you like more information about how those scientists set up the experiments, you can click the link at the bottom of the previous slide to see the actual articles. Welcome back again. I hope you have explanation for your results. Let's reflect on what you have learned. Please fill out a reflection question in the Google Classroom. Tell us what you have learned from this module. What is the distinction between observation and experimentation? Do all scientific investigations have hypotheses? Please explain. Can all scientific questions be answered through conducting experiment? Please answer and explain. So far, we have talked about prior knowledge and scientific investigation that relate to scientific reasoning. In the next module, we will focus on 3 types of reasoning: inductive, deductive, and adaptive reasoning. Thank you for watching. If you like this module, we also have another module that focuses on integrated STEM through agriculture for natural resources. Check out the module and website by clicking the link in the slide. If you have questions, feel free to contact me. Thanks USDA NIFAD for supporting the project. Thanks for the project co-director Dr. Neil Nabla and the graduate students Brianna Nielsen working with me and giving feedback to the module. Thanks for Dr. Crystal Hans serving as the content experts for the module. See you next time.